Alright, in this first video we're doing Unit 1, Topic 1 for Honors Geometry, Semester A. These are the formulas that you'll be given. The first two, Pythagorean theorem and trig, are used for right triangles only. This is the Pythagorean theorem, a squared plus b squared equals c squared. Remember, c, the loner, is always across the 90. And these formulas, this is just a fancy way of giving you SOHCAHTOA. And you can see it right here. Sine is O on top, H on the bottom. So cosine C A H TOA C O A. So these are only for right triangles. Bottom, you have formulas that you can use for non-right triangles. So you have the law of sine. Remember, sine always takes in an angle. So these are angles. And you have the law of cosine, whereas this is the angle. And then finally, this formula, if they ever ask you to find the area of a triangle and it's not a right triangle, you can use this formula. Again, this is an angle. So let's get started. 1, the 3 undefined terms of geometry. Please know this for your exam. It is point, line, plane. Not point, line, segment, not point, line, ray. It's point, line, plane. Plane is the one that's mixed up. For angle bisector, if this is 120, they're asking you to cut it into 60 and 60. So you take out your compass, you draw the angle. Okay, I do mine a little bit too big, no big deal. Erase, draw again. Find my angle. And then you put your sharp edge on the side and you cross your angle. Sharp edge on the side. And you cross your angle again. Your two crosses should meet. If they don't, try again. But mine mean right there. So I'm going to take a ruler or whatever you have. Oh yeah, not working. But here you go. And you connect this with the dot, and that will cut the angle in half. Alright, number 3. So it says construct a 45 angle. So it's important to know that 45 is half of 90. So you're going to create a 90 degree and then cut that in half. So to create a 90 degree, you put your sharp edge here on the dot and make a semicircle. You want to extend the line. And then you want to do a perpendicular bisector of this and this. So basically, this, when you cut this in half, you'll have a 90 degree at B. So sharp edge on the dot, and make sure you're more than half, which I'm not. So that way. And then do semicircle. Sharp edge here, semicircle. And then connect right here to right here. And then you will be halfway done. And there's your 90 degrees. Now you want to cut that 90 degree in half. So you put your sharp edge here, and make a mark. Oops. Sharp edge here, make a mark. Hopefully your marks meet. Mine be right here. And cut that 90 in half. 45. Alright, next page, number 4. they want you to make a parallel line. Now there are a million parallel lines. This is one, this is one, this is one, but there's only one in the whole entire world that's parallel that also goes through this point H. So they want that one. So to do that, the first thing you do is you take a ruler and you connect the point with the line. So I'm going to connect it this way. Voila. All right. And then you're going to take your compass and draw the angle that you want to copy. I'm going to draw an angle right here. Draw an angle by putting the sharp edge on H. Okay, and I go backwards. So the sharp edge is on H, and I'm going to draw my finger and switch. So if this is, I don't know, 50 degrees, then I want this to be 50 degrees. But right now it's a lot more, so I want to cut it. So I get what I call the wingspan of this angle. Like that. So it's about that wide. And I put it right here where the two lines met. And I cut this angle right here so that it's exactly the same width as the first angle. And I'm making a parallel line by connecting those two dots. Now, if your line, obviously you can see my line doesn't look exactly parallel. That's okay, as long as you have all the marks. Oops. Okay. I think we have a couple more questions. 5, 6, 7. All right, number 5. The perpendicular bisector of AB is constructed. So if you have AB right here, perpendicular bisector is going to make a 90 degree and is going to cut it in half. Okay, so it's going to look something like that. So that's me. What is true about every point on the perpendicular bisector? So as you can see, all of these points are equidistant to the end. So what I mean by that is this point is the same distance from A to B. This point down here is the same distance from A to B. So the correct answer is what's true about every point? It's equidistant to A and B. All right, number 6. Angle bisector of angle CDE is constructed. Okay, so you have an angle CDE. Remember, D is in the middle. So CDE. And they cut this angle in half. Ooh, that's bad. Try again. That looks too much. What's true about every point? So for this one, every point on the angle bisector is equidistant to the side. So if whatever this is, whatever this is, so the correct answer is equidistant to the... Alright, and finally the last question of Unit 1, Topic 1. A line is constructed parallel to a given line. So you have a line, and then you make a line that's parallel to it. What is true about the line? Well, they're parallel, but you don't want to use the word parallel because you never want to use the same word in its definition, right? So you want to say the line will never touch. And if you want to sound really, really good, you will say they'll never intersect. I hope you enjoyed my first video.